Okay, so now that we've seen a little bit of classes, let's take a closer look at some of them and deal with a good practical example. So what we're going to do in this video or in this tutorial section is that we're going to create a class or a class for general pets, and we're going to give them some general properties. And then later on, we'll go on to make inheritance classes, so we can make a dog and a cat, for example, and we'll also do some interaction with them. But let's just start off with the basics, and let's just start off making a general class for a pet. And so this pet would just have all the kind of general properties that all pets would have, or at least some of them. So the ones that we would be interested in, or the ones that we would want to use. So to make a class, we'll just use the keyword class at first. So this is going to define us our class. And then we'll make a space, and we'll put in the class name here, which in this case is going to be pets. Or we can have it be a pet like this. And then we'll put in a colon here, and this is just gonna start our class. So now we've got our class definition here. Okay, so let's go on. And the first thing that we need is an initializer. So as soon as the class gets called, we need to assign it certain values. So like we need to kind of build it up. We need to allocate all the properties. We need to assign memory and all that stuff. So if we want to create a pet, we need to initialize it. So we need to kind of create it. And so for this, we need the initializer. And since the initializer is a function that you have to overwrite, you actually have to do the double underscore, and then you write init, and then another double underscore, and then you open and close the parentheses, and afterwards you put in here a colon. So this is going to indicate that you're going to start your initializer here. And so we're inside the class pets here, and this is going to be our initializer, and we remember we need this double underscore here because the init function already exists kind of inside of Python. So this double underscore lets us overwrite it so that we can redefine it. And this will automatically get called once a pet is created. So because this already exists, this is also automatically going to get called when a pet is created. And so that kind of takes care of itself. And now we remember inside of a class, we need to put, well, the first thing that we want to do is when we create like a function or something, is that we need to put inside self so that it refers to itself. And then we can start putting in the variables. So our first input here is always going to be the self. And let's just think first of some variables that we want to put in. And then we can kind of put them in as input in the top here. So some variables that we may want to create would be a name, for example. So every pet is going to have a name. So to assign the name to the pet class, we actually have to do self.name. And so now this makes name a property of the pet. Because we have the self here. So the self makes name a property of the pet. And we have this dot here because it's acting on itself, and we're giving it, or we're creating the variable name. And so this is one of the, and we'll define these in a second, but let's just kind of write them down first. So this will be the first variable name that we're going to have. The second variable is let's give every pet an age too. So we'll create the second variable self.age. Like this. And then every pet is going to have a hunger level. So they're either going to be hungry or not hungry. And so we'll create a self.hunger. So these are all properties of the pet. So hunger is a property of the pet, age is a property of the pet, name is a property of the pet. And the last thing that we can do maybe is just set a playful. So are they playful or not? So like a kind of true or false. So we can do self.playful. So these are the variables that we want to deal with. And we want to initialize them from input so that we want, when the class is created, we want these variables to be given in by the user or by the program. And then we'll create the pet accordingly. So we need to have the inputs up here. So we can start putting in our input variables here, and we can put in our name variable, or we'll just do shorthand, and our first input we're going to save an n, and that's going to be our name later. Our second input is going to be the age, which we'll do A. Our third input is going to be the H, which is for hunger, and our last input is going to be the P for playful. Now, you may remember, or you may see that this is very, very similar to functions. So we just have all the input that goes into functions here. That's all inside of these brackets for the initializer. And so now we can assign these values by making the self.name property equal to n, and we can make the self.age equal to A, and the self.hunger equal to H, and the self.playful equal to P. Now I used NA, H, and P for the name, age, hunger, and playful up here, just so that it doesn't cause any confusion, but usually what you can also do, or what's usually done, is you even just write name up here, and then you can write name down here. I just didn't do that right now because I don't want you to assume that you have to have this variable name up here, so that's not the case, but it's often done just for convenience because it applies. So maybe we can leave the name here so that we can see both options. We can use name, and then we can assign the name of the pet to be the name that we put into the function, or into the initializer, but we can also use other variable names like A, which is going to be short for age, or H, which is going to be short for hunger, or P, which is going to be short for playful. So we can really just kind of choose our variable names, but very often this is done just for convenience because it makes sense that this variable is called the name and that we save the name in the name. Yeah, so this is our initializer. Now, what we can do afterwards is we can create a get function. So let's go on with that. And what we're going to do with a get function is we're going to it's going to give us the properties. And something that we forgot by the initializer is because it's a function, we have to actually put def in front of it. So now it's going to give us this bold text and everything. So since it's a function, we have to actually define it with the def keyword. And now this is the function kind of syntax that we know. Okay, but yeah, so now we can move on to defining other functions. And very common functions that you define are something called setters and getters. Now, setters are functions that take in a variable and they set a variable. So we'll see an example of that in a second. And getters are just functions that return a variable. So let's just define a simple getter so that we kind of have a bit more practical understanding of what a getter actually is. So we can add a comment here and just write getters, and everything below here is just going to be a get function. So let's define the get function for name. So we'll write the keyword def, and then get name, and then we'll open and close the parentheses. And the only input that we're going to have here is going to be the self. So there's not actually going to be any input, but we need the self here because we're referring to the class. And then we have the colon here. And so all this get name is going to do is it's just going to return the name. So what it's going to do is literally it's just going to return the self.name like this. So this is this is pretty much what a get function is. A get function just gives you the value back. So you can get the name by just doing pet.getName. So this is the example of a get function. Then we can do a set function. So we can do a setter here, and a set function, very similar, kind of the opposite of a get function, is that it's also a function. So we start off with the keyword def, and then we write now set name and open and close parentheses because it's just like a function, and then we put in self first because we're inside of the class, and then the comma separator, and then what we're going to put in here is we're just going to put in a name, and then we put in the colon because it's a function definition. And what we're going to do inside here is we're going to change the self.name to be equal to the name that we put in here. And now you shouldn't confuse that, like, this name here is not equal to this name. It's just the way we call the variables. So we could even call this x, and we could call this x, or we can call it x name, maybe an x name, just to really show that the variable namings don't have to be of a specific type. Like this name here doesn't have to be equal to this name. This name here doesn't have to be equal to this name. If this name and this name is equal, that doesn't mean these two are the same. This is just a function parameter, and it's only defined locally. If you remember from earlier how variables are kind of given a scope. So this variable inside the function, that's a function parameter, only exists inside of this function. So we don't have to worry about it outside. But yeah, let's just leave it as xName just to kind of avoid confusion. But generally, you would also just write name here because it's because that's the best variable name because it applies, because it really is the name. So it's usually just write name here because it fits. But let's just, to avoid confusion, use xName here so that we can see kind of the different ways of naming the variables and really notice that it's pretty much not important what you call your variable. Okay, so this is an example of a get method. This is an example of a set method. We can define the get methods for the other ones too now, so we can do a define, and now we can define the get age, and then we open and close parentheses, and inside here we put again the self, because we're acting on the self, and then the colon here, and here we just want to return the self.age. So our get age is just going to return the self.age. We always need the self variable inside of the brackets because it's part of the function, and it needs to be able to refer to itself, so we need to put the self in here. Now we can do the same thing for the hunger, so def get hunger, and then we put inside here, you open and close the brackets and put a self here, and then we put the colon, and then in here we're just going to return the self.hunger, like this. And then finally, we can also define a get playful. And then we open and close brackets here and put in a self and a colon, and then we return the self.playful, like this. So these are all our get methods. Now we can also do our set methods, and we can define a set age. And now as input we take a self, but we also need to take in the new age that the user is going to put in, or that the program is going to put in. So our next variable name, we'll call it, let's call it age with a capital A, just because, so that these variable names aren't the same. But it can also be with a lowercase, it doesn't matter. And then here in the set age, we'll just set the self.age to be equal to the age. And then we can define a set hunger, def set hunger, and here we open and close again, parentheses, the def keyword again because we're defining a function, and then you guessed it, we put in the self, and here let's actually just use the same variable name, let's just use hunger, like this. And I'm just using all these different cases just to show you it really doesn't matter what you put here as this variable name. This is really just for your convenience. And so here we'll make the self.hunger be equal to the hunger. And finally, we can define a set playful. And here we open and close the parentheses, and we put in self. And here we put in, well, let's call this variable play, like this. So, and in the set playful, it's going to take in a variable called play, and we're going to set the self.playful, so this playful property of the class, to be equal to the variable or the input that we put in here. So what are we doing, or what have we done? We have created a class, or we've defined a class, a general class that we can use. We've created an initializer. And so what this initializer does is it initializes everything. It kind of sets everything. And so we assign, so these are all going to be user inputs, or these are going to be program inputs, the name, the age, the hunger, and the playfulness. And then we're going to set the name and age and hunger and playfulness of the class. So the self dot actually means that it's a property of the class. So the name, the age, the hunger, and the playful belong to the class pet because we have the self dot in front of it. And now what we do here is we just return the name of the pet, we return the age of the pet, the hunger of the pet, and the playfulness of the pet. And here we set the name of the pet by user input, so this is going to work just like a function, and we'll put in a parameter here, and that's going to change the name. This parameter here is going to change the age. This parameter here is going to change the hunger, and this parameter here is going to change the playfulness. So yeah, let's just create a simple pet. And we can call or we can save the pet in the variable called, let's just call it pet1. So this is just going to be a general pet1, and it's going to be equal to, and now we actually want to create a pet of the pet class. So what we do is, since our class is called pet, so we type in the keyword pet, and now we open and close parentheses, and now we see we need to put in, so for the initializer, we never have to put in a self. We have to put in a name, an age, a hunger, and a playfulness. So the name, we can call them Jim, maybe capital J here. The age, we can have them be, well, let's use integers. So we can have them be 3 years old. The hunger is going to be false right now. Capital, false. And the playfulness is going to be true. So you can see we can also put in all types of different variables here. And yeah, we can just use all that. So we're not restricting ourselves to anything just because these are general Python variables. So we can have a general name, general age, it can be integer, it can also be a string, it can also be something else, it can be a float or whatever you like. And we'll just use Boolean values for the hunger and playfulness. So yeah, so now we've created this pet1. And maybe let's just print some properties and then we can run it. So let's print first pet1 dot, and then let's just get the name, get name, like this. Okay, so let's just run this first to see what we get. And so when we run it, we see this created, so pet1 is now a pet, and what we've done here is we've looked at pet1, and the dot indicates that we go inside pet1, or inside the pet class, and we call the function, or rather the method, which is, method is a function that belongs to a class, we call the method getName. And what getName does is it returns the name of the pet. In this case, the name of the pet is Jim. And so we see Jim here. Now the next thing on the next line, we could maybe print from pet1, let's get playful, like this. And so we open and close parentheses. We always have to open and close the parentheses here because we're calling a function, like this. So the get playful is a function, or it's a method. So we still have to open and close the parentheses, and the dot indicates that it's going to be, that it's part of the pet class. So let's run this, and we see we get Jim as the get name, and we get pet1 as the get playful. And now let's maybe set the name to something else. So pet1 dot set name, and now in here we can type in a new name. So let's rename our pet from Jim to Snowball. So let's give it a more pet-like name. And then let's just get the name of pet1 again. So we can print, and then from pet1 we access the method getName, and we open and close the parentheses. So what we've done here is inside of pet1 we got the method, or we accessed the method setName, and we put in the name here, or the X name. And you notice we don't have to put in the self, we only have to put in the variables here. So in this case we put in the string snowball, and what that's going to do is onto pet1, it's going to change the name of pet1 to be the new name that we put in here. And so when we get this new name and when we print it, we can see that first we start off with the name Jim, and who is playful, and then we change the name, and now we get the new name and we get Snowball. So generally these functions are kind of redundant in Python, because in Python something else that I can do is just I can print and I can access the names directly. So for example, in pet1 I can just access the age as we see here, or the name. So I can also do just pet1.name. So I don't actually have to do a get here. I don't have to do a get name really because I can just access it. So if we just run it, we see that the get name function, or the method that I call, returns the name of the pet. In this case, it's Snowball because we changed it. But I can also just access the name directly. And because I can also just access the name directly, I can also change it directly. So if I go into pet1 and I go into the name, and I can just here make it be equal to, well, let's just make it Jim again. So we're changing it from Jim to Snowball, and from Snowball we're changing it back to Jim. And then here we can print out again pet1 dot get, or well, we can actually just use the name like this. So we can print out the name again, and let's run this one more time. So we see is first we print out the name Jim from get name, then we print out true from get playful, so we return the playfulness. Then we change the name to Snowball, so we use the set name, which does this. Here it sets the name of the pet to be equal to the new name. Then we print the new name using the get name method, so we print Snowball. Then we print the name just accessing the name variable, or the name property of the pet, and we also get Snowball. And now we just access the name of the pet1 directly, and we change it back to Jim. And now we also just print the name directly without using any methods, so we get Jim again here. So we can see that in Python, it's not that big of a deal to put in get and sets, because I can access the names directly, or the properties directly. There are ways that you can make them private so that you can't do this, which may be a nice way to do, for example, if you don't want someone to have direct access to the properties, if you want to have them like protected so that, or have them be private so that people can access them directly. But generally you can just access these properties like this. But the point is also to show you the way that we can kind of use input here in functions. So just because we have a self here, we never actually put the self here or anything. We only start with the actual variables. And so this is how we would call a function of a general class. And we see the same thing up here. And so this is just kind of a general example just to get us into it. And the next thing that we're going to do is we're actually going to expand upon this a little bit. So instead of just having a general pet, we'll make a subclass of it. So we'll do some class inheritance. And from there, we're going to make dogs and cats, which are also going to be pets, but which are going to have more features of their own. So now that we've just created this pet class, let's expand upon it a little bit. And now let's first make a class called a dog. And this dog is also going to be a pet. So this dog is going to inherit some properties of the pet, but it's also going to have some of its own properties. So yeah, let's just jump right into that. And we can just take out all of these print statements right here so that we have some more time to code. So we can still see all the output from last time. And so what we can do now is we're going to define our class dog. And so what we're going to do is we're going to write class. So this is going to indicate that we want to create a class. And then we're going to put in the class name, and the class name is going to be dog. And now, because the dog is going to inherit some properties of the class pet, to do that, we have to open and close parentheses after the class name, so in this case dog, and inside here we want to put the class that the dog is going to inherit some properties from. So in this case it's going to be pet. So what we're doing here is we're creating a class called dog, and this dog is going to get some properties from pet. So it's going to get the name, the age, the hunger, and the playful values, and it's also going to get all these functions or these methods associated with it. So the dog is going to get all of this, and so this kind of prevents us from having to rewrite everything. So we don't have to write all this again. We're just saying the dog is going to get all of these because the dog is also a pet, and the dog has all of these properties. Okay, so let's just start off. And so the first thing that we need to do, like always, is we need to write an initializer. So we're gonna do our def, and then we're gonna write the initializer. So we're gonna do the double underscore, and then the init keyword, and a double underscore again, and then open and close parentheses. And so the first thing that we need to put in here, because it's a method, it's part of the class, is the self keyword. And then we're going to need to put in some other parameters too. But first we can stick with this. And then let's just put in a colon here. And so this is going to complete our method definition, or our function definition. And so let's just first choose what kind of properties we want the dog to have additionally. So what we want the dog to have is we want the dog to have, we want to have a breed. So we want to know what breed it is. So we're going to assign a breed, a breed property to the dog. So we're going to do self dot, and then we're going to create breed is going to be equal to, and then, well, we'll put that in a second. So we'll just leave this blank for now. And let's also give the dog a favorite toy. So we'll do self dot favorite toy. And so this is going to be the second property that the dog is going to have. So the dog is going to have a breed, and it's going to have a favorite toy. So we'll make that equal to whatever we're going to call the variable in a second, and then we can put that down here in a second. So what do we need to put into the initializer here? Well, we need the breed and the favorite toy, but we also need the name, the age, the hunger, and the playfulness for the pet, because the dog itself has a breed and a favorite toy, but it also has all of these properties that a pet has. So it also has a name, it has an age, it has a hunger level, and it has a playfulness status. So what we need to take in is we need to take in a name, we need to take in an age, we need to take in a hunger, and we need to take in a playful. And then additionally, we're going to need a breed, and we're going to need a favorite toy. Favorite toy, like this. And so we can directly assign the breed to be equal to the breed, and the favorite toy to be equal to the favorite toy, like this. So what we're doing here is we're initializing the dog class with a lot of parameters now, and we're creating the property breed that's part of the dog, and it's going to have the value that we put in here for the breed. And we're creating the property favorite toy, and that's going to have the value that we put in here for the favorite toy. Now you remember this variable name here and this one doesn't have to be equal, just like it didn't have to be equal up here. But in this case we just made it the same just for convenience, because it makes sense. Because this variable is going to be the favorite toy, and this is going to be the property that is the favorite toy of the dog. So they don't have to be the same name, but we're just doing it like that because that's what it's usually done, because those variable names make sense. And so the last thing that we need to do is we also need to initialize the pet. So we need to call the initializer of the pet. So how do we do that? Well, we go into self dot, and here we need to call the initializer. We need to call the initializer of the pet class, and yeah, and then we're going to put in all the properties of the pet. So we're going to put in name, age, hunger, and a playful. So that's what we're going to put in here. Oh, actually, this shouldn't be the, so this shouldn't be the self, because the self is referring to the dog. This should actually be the pet, because we're referring to the pet class. So this is the initializer of the pet. So the self belongs to the dog, but the init, or the initializer that we're going to call, actually belongs to the pet. So this is the one that we want to use. We want to go into the pet, and in the pet we want to call the initializer with these properties. So inside of this class, we want to call the initializer, this one, and we want to set these properties. So what we're doing is, because our dog is a pet, it takes all the properties of a pet, and inside of the pet class we're going to call the initializer here, and we're going to give it all these parameters, and what that's going to do is it's going to set the name, the age, the hunger, and the playfulness for us, like this. So now we've initialized our dog, we've set the individual properties, the breed and the favorite toy, and we've also set the name, age, hunger, and playfulness through using the initializer that the pet has, and that the general pet class has. So now we can also define some simple functions for the dog that are different from the pet. So maybe let's use the favorite toy, and let's create a function called wants to play. So we'll just write def, and then the function name is going to be wants to play. And then we open and close parentheses, and inside here we put in the self, and then we put a colon here, like this. And so this is going to be a method that's going to be from the dog, so the dog can call it, and this belongs to the dog, and so we have the self keyword here too. And what this is going to do is we're going to check if the dog is playful, so if playfulness is true, and if it is true, we're going to tell or we're going to return that the dog wants to play with their favorite toy. So what are we going to do? Well, we're first going to check if the playfulness is true. So if the dog's playfulness is true, so the dog, because it inherits all the properties of the pet, it also has the self.playful property. So if the self.playful property of the dog is true, or so is equal to true, so if the dog is playful, then what we're going to do is we're going to return, and then we'll open and close parentheses here because we're going to return a string. So what we're going to return is dog wants to play with, and then we'll also put in here the favorite toy. So if the dog's playfulness is true, we're going to return dog wants to play with favorite toy. And if it's not true, so else, we're going to return the dog doesn't want to play. So what we're doing in the wants to play, so we forgot one thing here in the if statement. We have to have the double equals, not the single equals, because we're making a comparison. So the single equals is the assignment, like we have up here, and the double equals checks if the values are the same. So yeah, we should be careful of that, the double equals and the single equals. So what the wants to play function does is it checks if the playfulness of the dog is true, and if it is, then we say the dog wants to play with their favorite toy. Otherwise, we say that the dog doesn't want to play. So yeah, let's just create a dog right now and see an example of this. So what we're going to do is we're going to create actually, let's call the variable a husky dog. Husky dog. And this variable is going to be a dog, and it's going to have, the name is going to be, what's the name going to be? It's going to be, well, we'll just call it Snowball again. And then we'll put in an age, and the age is going to be 5. And then we need to put in a hunger, so we're just kind of following this list here. The hunger is going to be false, the dog's not going to be hungry. Playful is going to be true. The breed is going to be a husky, hence the variable name husky dog. And the favorite toy is going to be a stick, just like this. So we have to put in all the properties of the initializer, like this. So the name comes first, then the age, then the hunger, playfulness, breed, and favorite toy. So these are all the corresponding properties, and they go kind of element by element here, or yeah, element by element. So it's pretty much just like calling a function. Just the syntax is a little bit different. So we're just creating a dog class here. Okay, so now that we've created a dog, let's see if the dog wants to play. So we'll create a variable called play, and we'll make it equal to, and then we'll access the husky dog. And so we'll take the husky dog, which is this dog, and we'll access the function or the method wants to play, and then open and close parentheses. And we don't have to put anything in here because it's just the self. So yeah, that's all that we're gonna have to do. We're just checking if the husky dog, and then inside this husky dog, we're gonna call wants to play on the husky dog. And so since this dog has a playfulness of true that we set here, it's gonna see that the playfulness is true, and it's gonna return to us the dog wants to play with the favorite toy. And it's not gonna print it, it's just gonna save it in this variable. So what we can do in the end is we can print play, like this. And so what play is this string here. So this is given back from the method, and it's saved in play. And then we can save it here. We can print it out here because we've saved it in here. So let's run this. Oh, missing one positional. So what are we missing? Name, age. We're missing a self in here, of course, because yeah, well, we're inside a class, so we always have to put the self. So now, we also misdefined our favorite toy because once again we have to access the self. So you can see here it's very important that we access the self. So the self refers to the property of the dog class. And so favorite toy in and by itself, even though we had it here in the initialization, doesn't make any sense. So if we want to access the properties of the class, we always have to use these self keywords. Or else, as we see here from these errors, the program or the computer doesn't really understand what we're trying to do. So we have to indicate that it's the favorite toy of the class that we're going to return, because otherwise this variable isn't defined. So if we run it now, then we see the dog wants to play with stick. And so that's what we get from here. And now if we make, so we can change afterwards, or we can change the playfulness to be false. So inside the husky dog, we can look at playful. So in the husky dog, we're taking the playful property and we're going to be setting it equal to false, like this. And now if we do the same thing as above here, and we just use the variable play again, and we make it equal to, and then we access the husky dog, and inside the husky dog, we check again, wants to play. So we call the wants to play method on the husky dog, and then we print play. So we're doing the exact same thing as above here. We're calling this method on the husky dog. The only thing is now that we changed the playful to false, this is no longer going to be true, and we're going to get the dog doesn't want to play, which we see here. So first, the husky dog wants to play because it's true, and it wants to play with its stick. And then we change the playfulness of the husky dog to be false, and then we check, does the husky dog still want to play, and we print it out, and we see, no, the husky dog does not want to play. Alright, so now that we've created a dog, that's a pet, let's also create a cat that's a pet. So we're going to do the same thing that we did with the dog, except we're going to do it with the cat now. So it's going to be very similar. We're going to create a class using the class keyword, and the class name now is going to be cat. And the cat is also going to be a pet, so we're going to open and close, which means it's going to inherit the properties. And it's going to inherit the properties of a pet, just like this. And then we'll put the colon here to indicate that we want a starter class definition. And then we go to the next line. And so here we start again with an initializer, just like we did for the dog. So we'll define, and then underscore underscore init, underscore underscore, open and close parentheses. And now we need the self because this is inside the class, and every function needs to, or every method needs to have the self because it's going to be part of the class. In this case, it's going to be part of the cat. So we need the self to be able to refer to the cat. And so what do we need in the initializer? Well, let's put a colon here and let's first define the variables that we want for the cat. So for the cat, we're just going to create one variable, and that's going to be the favorite place to sit. So we're going to create the self dot favorite place to sit. So this is going to be the attribute of the cat. So the cat is going to have all the attributes from the pet, which we see up here, the name, age, hunger, and playful. And it's also going to have its own attribute, which is going to be the favorite place to sit. Yeah, so let's fill out the stuff on top here first. And so what we need from the pet is we need a name, an age, a hunger, and a playful. So those are things that we're going to ask for first. So we'll ask for a name, then the next input is going to be an age, then we need a hunger, and then we're going to need a playful, just like this. And now what we need to do, just like above here, we also need to initialize the pet. So we're going to go into pet, and inside this pet we're going to access the initializer, so the underscore underscore init underscore underscore, like this. And here again, we need to refer to the self. And then we're going to put in the name and the age and the hunger and the playful. So this is going to initialize our pet. And now we still need one more property, which is the favorite place to sit. And so here, our last input is going to be the place. And we're going to make the favorite place to sit be equal to the place. So what we're getting here for the cat is we're going to ask for name, age, hunger, and playful, and we're going to ask for a place. And we're going to use the first four inputs to create or to initialize the properties of the pet that correspond to the cat, so the name, age, hunger, and playful. So we'll use the pet initializer for that. And then the last input, the place, we're going to use to define the favorite place to sit for the cat, so hence the self. And now you see up here, for the dog, we use the breed and the favorite toy. But for the cat, we don't have that. We only have the place. But what's in common with these two is that the dog and the cat, since they are both pets, they both have name, age, hunger, and playful, which we see here. And we also see the name, age, hunger, and playful here. But the dog has the breed and a favorite toy, like this. So it has a self.breed, so a breed attribute that's for the dog, and a self.favorite toy, so a favorite toy that's part of the dog, whereas the cat just has the favorite place to sit. And so that's why we need to ask for the place here, but we don't need to ask for the breed and the favorite toy, because the cat and the dog are on the same level, and the cat's not going to have these properties. It's going to have different properties. And so we're going to create our own little method for the cat too. And what we're going to do is very similar to the dog. We're going to ask it if it wants to sit. So we'll write def to create a method, and their method is going to be wants to sit. And then we'll open and close the parentheses, and we need to refer to the self. And then we'll put a colon here, just like this. And now what we're going to do in the wants to sit is we're going to check if the cat is playful. And if it's not playful, we're going to print out the cat wants to sit in its favorite place. And if it is playful, we'll print out the cat wants to play. So let's check if it is playful. So how would we go about that? Well, first we need to use the if statement. So we're going to use if. And now we want to see if the cat is playful. So in the self.playful, so we're going to check the playful attribute of the cat, hence the self. So the self means that it's part of the cat, and here we're going to access the playful attribute. If this is equals to, so we're comparing it to, if it's false now, so if the cat is not playful, we're going to print out that the cat wants to sit in its favorite place. So the cat wants to sit in, and then we'll just add here place. So, we have to add the self.place because the place is, or we actually have to add the self.favorite place to sit. Since the favorite place to sit is the attribute of the cat. So the cat wants to sit in, and then we'll put in the self.favorite place to sit. So the self indicates that it's part of the cat, and then we'll put in here the attribute, which is the favorite place to sit. And so that's what we're gonna do if the cat is not playful. Else, so if this fails, we're gonna print out the cat wants to play. So the cat wants to play. Okay, so we can see a little bit of a difference here from the cat to the dog. So the first thing that we see is that the dog has a breed and a favorite toy, whereas the cat only has a favorite place to sit. And the dog has a wants to play method, whereas the cat has a wants to sit method. And in the dog, we check if the playful is true, and if it is, we return where the dog wants, or what the dog wants to do, or what it wants to play with. Whereas in the cat, we print it out. So let's just implement a cat, and then let's see that in action. So let's just create a typical cat. So that's what we're going to call our variable, the typical cat. And we're going to have it be equal to a cat. And now we need to open and close the parentheses to create the cat class. And now we need to put in all these attributes here. So name, age, hunger, playful, and a place. And so the cat's name is going to be Fluffy, like this. And its age is going to be 3. And so we're just going by this line by line. Its hunger is going to be false. Its playful is also going to be false. And its favorite place to sit is going to be sit in. Well, the favorite place to sit is going to be the sun, or not the sun, in the sun ray. So the ray coming from the sun, wherever that may be it on the ground coming through a window, or through an open door, or through a closed door that's glass, or whatever. It just wants to sit in the sun's ray. Yeah. So now we've created a cat that's Fluffy. This name is Fluffy. It's 3 years old. It's not hungry, but it's also not playful. And its favorite place to sit is in the sun ray. And we saved all this in the typical cat. And so we can now call, for example, the wants to sit. So we can go into the typical cat. And what we're going to call is we're going to call the wants to sit method. And then we're going to open and close parentheses. And now a difference that we see here in comparison to the dog is, so in the dog what we made the wants to play method do is we made it return something. And since it returns something, we should save it somewhere. And so we saved it in play. But since the typical cat or the wants to sit method in the cat doesn't return anything, it just prints it out directly, we don't need to save it anywhere. So if we call this, it's immediately just going to print the cat wants to sit in or the cat wants to play. So let's run this, and we can take out, actually we can leave in the dog just because. So we'll get the output that we have here from before. So we'll run this and we'll see that first we get the output from the dog. So the dog wants to play with stick, since the dog wants to play. And then we change the playful of the dog to be false, and now the dog doesn't want to play, which we printed here. So we saved it first in the play, and then we printed it just using the print. and now we created the typical cat, and we made it we called it Fluffy, age 3, it's not hungry, it's not playful, and its favorite place to sit is in the sun ray. And then we call the method wants to sit on the typical cat, and we see that the cat wants to sit in the sun ray. So nice. So we also see the difference here that the typical cat, the wants to sit method directly prints because we call a print here, whereas to print the play, we actually have to print the play. So just because we call the wants to play doesn't mean it's going to print. It's just going to return, and we're going to save that in the play, and then we can print it out. So we see these slight differences here. You can do either depending on what you need. So if you just want to print something, you can do that. Otherwise, if you want to return something, maybe you don't want to return the string like this, maybe you would print this, but maybe you would want to return like a playfulness like we have here, or some other attributes. So these are also different things that you can do. Okay, so we have this, and now let's do one more thing. So let's make a general statement for a cat, and let's make the cat kind of printable. So let's be able to call print on the cat. Now we've seen this before just a little bit, but let's just do it one more time. So what we're going to do is we're going to define, and what we're going to define is an str. So just like the init, we have to overwrite this. So we go underscore underscore and then str underscore underscore, and then we open and close parentheses, and we put in the self here and then the colon. And so what this does is, because we have the underscore underscore before and after, this means that this already exists, but we're overwriting it. And if we create this method here, what that enables us to do is it enables us to write print cat. And now we just have to put in the appropriate content here into the function, and then we have to call the print typical cat. So we have to actually print the instance of the cat, not the general cat itself. But because the typical cat has properties that we assigned here, we can print it. So we can print the typical cat, and we don't have to call anything on it. So let's just make a general. So we're going to make a return statement, and it's going to be return. And what it's going to do is it's going to return. What is it going to return? It's going to return the name of the cat. So it's going to return self.name. So this is going to be the name of the cat, plus, and then we're going to write some text here. So what are we going to write? Well, the name of the cat likes to sit in, and then we're going to add here the favorite place to sit of the cat. So self.favorite place to sit. And so what this is going to do, if we call the typical cat, is going to be that it's going to print out the name of the cat likes to sit in the favorite place of the cat. So we use the self dot to access the name of the cat, and the self dot here to access the favorite place to sit. And then we also put this together in a string, and it's going to print all this out for us. So let's run this code, and let's see that in action. So we see all the output from above. The dog wants to play with the stick, which we have from the play here. The dog doesn't want to play, which we have from the play here. Then we see that the cat wants to sit in the sun's ray. So we get that here from the typical cat wants to sit. So the cat wants to sit in and the favorite place to sit. And now when we call print on the typical cat, we see that Fluffy likes to sit in the sun ray. So this is this statement that we've created here. And this is because we've defined this underscore underscore str method. And so we've overwritten it, and that gives us the ability to call print on the typical cat. Now, because we didn't do this for the dog, for example, if we try to call print on the dog, let's see what we get. So what we see is we get kind of a general definition of what we, or kind of type or something here. So we get some information about the dog class in general, but we're not really printing anything out because it's not defined for this. So here we've redefined it, and for the typical cat, we were able to give specific output for specifically what we want to happen if we print the typical cat. Whereas for the dog, since we didn't design anything, this is just kind of the standard information that we get. Yeah. And so this str method is also really nice, because if you just print the typical cat, then, or if you just print any class and you have this method defined, then you can put in a lot of the information, so all the essential information. So in this case, we put in the name in the favorite place, but we could also just put in the name, the age, the hunger, and the playful, and all that stuff, so we can give out all the relevant information, and we can even put it into a sensical format by kind of joining it together in strings or something that we like, and then returning it out. And so we can kind of jumble up all the information that we think is relevant and that's representative, and we can show that back or we can give that back to the user, or we can give it back to the program to use however it likes. And I mean, we can define this in the dog too, and we can also define it up here in the string, in the pet. So if we do that, for example, let's say we also define a print or an str method for the pet, like we've done on here. So we go underscore underscore str underscore underscore, and then we look at the self, and then we have our colon. So this is just the general format. We have the def keyword, then the underscore underscore str underscore underscore. So this means we're going to overwrite this, and then we need the self keyword here. And now what we're going to do here is we're going to return, and what we're going to return is just, let's return self.name, so the name of the pet, and then we're going to add is with a space, and we're just going to say the name, and then is, and then self, whoops, so we need a plus here to join it together, self.age, and then we'll add another plus, and then write years old. And so one thing that we're also going to need to do here is we need to make, since the age, we put it in as an integer, so we need to convert it to a string, like this. So what we're doing is we're accessing the name of the pet, and then we're joining it together with the is string with two spaces, and then we're joining it together with a string version of the age, so the age is no longer a number, but now it's a word or a string, and we're joining that together with the years old. So if we were to print out the pet, then we're going to get the name of the pet is whatever, how many years old. But if we run this, what we see here is that even though we've created this method for the pet, because the cat takes on all the methods and properties of the pet, and here we're actually redefining, or we're overwriting this str method that we created in the pet. So it has a different definition for the cat than it does for the pet. And so we can see here the difference. So we don't actually get that the name and is and X many years old, because it's only defined for the pet, and it's not defined for the cat. Yeah. So this is just kind of examples of letting you see and becoming a bit more familiar with classes and inheritance and what happens when you inherit properties. So as we see here, the dog and the cat both inherit the properties of the pet, so they both get name, age, hunger, and playful, but they all have their own properties, so a breed and a favorite toy. We also see here that the properties don't overlap, so the cat has all its own things and the dog, and so, for example, when we call a print on the dog, we actually don't get anything, whereas when we call a print on the cat, we get something specific. So these are kind of on the same level, but they're separate, and they don't share these specific properties anymore. They only share the general properties. Yeah, so this is how inheritance works, and it's really nice to structure things. So we can see here that we start off with a pet, and then we create dogs and cats from that. And so the nice thing about this is that because we've created the pet before, we don't need to copy or recreate all these definitions of the set methods, for example, and the get methods, and initializing all this stuff. We don't need to redo that all for the dog. We're just going to say the dog is going to inherit all these properties, and then we can just put in the important things that the dog needs to have, and we still have access to all of these things here. Similarly for the cat, we just define the things that we think the cat should have, or the important things for the cat. But yeah, and then we just define those, and we just use the initializer of the pet to take care of setting all these variables so that we don't need to write them out ourselves. And we also use the inheritance to give us access to all of these set methods and all of these get methods so that we can call that too on the class. So we can call that here on the cat too. So we've had our examples from before with the cat and the dog and the general pet, and we've seen examples of inheritance and how each inheritance class has its own kind of special properties as well as the general properties here, just like here, and its own kind of methods. And so one more thing that we're going to do is we're going to create another class that's completely independent of all of these, but we're going to save some of these classes inside the class. So that sounds kind of weird. What do I mean really? Well, what we're going to do is we're going to create a human, and we're going to give this human pets. And so the human class is going to store the pets that they have inside of an array. So we're going to store a class inside of an array in another class. So let's see that in action. So we're going to create a class, and this class is going to be a human, and it's not going to inherit any properties from anything, so we don't have to open and close any parentheses or anything. So we put a colon here, and now, just like anything else, we need an initializer, so we do def, and then the underscore underscore init underscore underscore, and then we need to put in the self. And now what properties do we want the human to have? Well, we want the human to have just a name and pets. So the human is going to have a name and it's going to have pets. And what we're going to do is we're going to make the self dot name. So we're going to create a name, and the self dot name is going to be equal to the name that we put in here in the initializer, and the self dot pets is going to be equal to the pets that we put in here. So the name that we're going to put in the form of a string, and the pets we're going to put in the form of an array. And then the next thing that we're going to do is we're just going to check if the human has pets. So we're going to write a little method that checks if the human has pets. And so we'll write def, and then we'll call our method has pets, and we open and close parentheses, and all we're going to put inside here is just the self, and then we'll put our colon here to indicate that we want to start the function. And then what we're going to do is we're going to check if the length of pets, if it's not 0, that means that the human has pets. So if the length of self.pets is not equal to 0, we return yes. And else we return no. So what do? We've created a method called hasPets, and we open and close the parentheses because it's just like a function definition. We need to put the self inside here because it's a method that's part of the human, so we need the self here. Now we're checking if, and then we're looking at the pets, the property of the human, and we're checking how long it is. And if it's 0 length, that means there's nothing inside, that means it's empty. If it's 0 length, which is going to be the else case, then we're going to return no. But if the pets variable is not 0 length, that means there's something inside, which means the human has pets. And so we'll return a yes. And so that's the only thing that we'll do right now. And then let's just create a human. So we'll create your average human. So we'll call the variable your average human. And we'll make it equal to a human. And the name is going to be, what is the name going to be? The name is going to be Alice. And the pets are going to be, and now we want the pets to be in an array. So we're going to kind of put them in manually here. So we'll open and close square brackets just to create an array. And what we're going to put in here is we're going to put in the husky dog, and the second element that we're going to put in is your typical cat, like here. And so this is going to be this is just going to be an array that contains, first of all, our husky dog, and second of all, our typical cat. And so these are going to be saved in the pets here. And so on the human, let's make a variable called has pet, and we're going to make it be equal to, and then we're going to check on your average human, and we're going to call here has pets, like this, open and close, and then let's just print out the response that we get, so has pet, and what we see from here is we're going to get a return of yes, because our pets property of the human is going to be an array that contains the husky dog and a typical cat. And so its length is going to be 2, so it's not going to be 0, and so we're going to get a yes back. So if we run this, we see we get a yes down here, so our human has yes. And so something that we see from here too, so this class definition, what we get is because we put in the general dog class here, we didn't actually put in our husky dog. So if we put in our husky dog, so this dog is just a general class, and we didn't define it as anything. It's just kind of an abstract thing. And so if we're calling the print on the dog, that we're just kind of getting information about the dog class. But if we run this again and call it on the husky dog, what we see is what we get from before is that it inherits the property of the pet, and we see here that Snowball is 5 years old. So we get the name of the dog is, and then 5 years old. So that's what we defined our husky dog to be like here. But yeah, so that's just a little short thing. That's also why we got this class main dog thing. So this is just information about the abstract class dog up here. And it wasn't any instance of dog, so we didn't make an implementation. It's just kind of the abstract class. And so this is the information that we're getting about that. But we see what we care about really is that the human has pets. And now we're going to access these pets, and we're going to do stuff with them. So because the human has pets, we can go inside and we can print, for example, if we go into your average human and we want to access the pets, and let's access the first element of the pets. So in this case, we're going to access the husky dog. Then what we're going to do, so let's just run this. And so what we're going to do, as we see here, is inside of your average human, we're going to look at the pet, the first element in the pets attribute of the human. In this case, it's the husky dog. And the husky dog is the dog that's named Snowball, that's 5 years old, that's not hungry, but it's playful, and it's a husky, and its favorite toy is a stick. And now if we call the print on the husky dog, we see that we actually get the method called from that we defined here in the pet. And since the dog inherits all the methods and properties of the pet, this is what we get for the dog. So the dog is printing out the print function, or the string, the str method that it inherited from the pet. And so we see Snowball is 5 years old. And now if we call this on the cat, so if we call this on the second element, for example, in the pets, which we saved to be the typical cat, and what we see from here is we see the print statement for the cat. So we see Fluffy likes to sit in the sun ray. And so what we're really doing here is inside of our average human, which is a human, and the human has pets, and this pets variable that belongs to the human is the array husky dog and typical cat. And so when we access the first element of the pet stored in the human, we access the typical cat. So all of this gets replaced by the typical cat. And now when we print this, we see, for example, the print or the str method, the override method that we've created for the cat, in which case it's the name of the cat likes to sit in and then their favorite place to sit. And so we can see here that we can even save classes inside of other classes. We can save them inside of arrays. They don't lose their functionality. We can still access all of them. We can still access all their methods. We can still access all their elements, all their attributes, all their variables. So, for example, we could go in here and we could look at the name like this. So what we're doing here, so like before, we're going inside of our average human. We're looking at pets. We're looking at the pets that are part of the human class. And so this pets variable that's part, or this pets attribute that's part of the human is the input here. And the input here is this array here. And this array, or this list, stores two classes. It has the husky dog and the typical cat. And so the second element of the pets stored in the average human is the typical cat. And so all of this here is really just the typical cat. And now we call the .name on the typical cat, or we access the name attribute of the typical cat, and then we get the name of the cat. So for example, if we change this back to the first element, then we're going to get the name of the husky dog, which is going to be Snowball, like we see here. So we can see there's really no limit to what we can do. The class is just a nice way of kind of grouping related things together. So we can have a general definition that we may not use that often. We're probably not going to create a general pet. We're probably always going to know what the pet is going to be. And so we're just creating this so that other pets, like we've created here, dog and cat, can inherit these standard properties and can use them. And so that means we don't have to write them again all the time. We don't have to redefine them. We can just use them by having this inheritance here, and we can access all of them, and we can keep our next class much shorter because it's more specialized, and we only have to define, or we only have to create the things that are actually new and that we want to create. And so this is a nice way of keeping things very general and keeping them simple, and keeping and kind of grouping common attributes together. And then when we move down, we get more distinguished, and we get more distinct properties. So we get the dog and the cat, which are now not general forms like pet, but they're different. They're more distinct. And then you can even go down more, for example, and you can create a Labrador or something, or you can create a special class of huskies that is a dog, so it would inherit all the properties of a dog. And you can just keep going down like that. And then we can also see that we can create a human, or any other class. It really doesn't matter. We just called it a human, but that doesn't make it a human. That's just the name we gave it. And inside of here, we can create any variables. And inside of those variables, we can save any data that we like. In this case, we decided to save an array that contains two instances of two different classes. The first instance is a husky dog, and the second instance is a typical cat. And we saved all of that inside of the pets attribute that belongs to the human. And then we were able to access it down here, and we see that we can call the general methods. So like we saw the print being called up here, on the cat, for example, but we can also access the attributes like we see here by accessing the name or anything. So it's really nice. Classes are really great. They're a nice way to kind of organize related things too. Structure, and you can structure things so like we can create many dogs and they're all going to have the same features. And that really helps us in programming too, that we don't have to recreate all these things over and over again. We can just make a general grouping like we did here, and we can create many instances of them, and they're all going to have the same properties, or they're all going to have the same general properties, their names and their actual other ages and favorite toys and whatnot may all be different, but they're all going to have the same things that we can access. So they're all going to be able, for example, the dogs are all going to be able to, we're all going to check if they want to play or not. So those are really nice things that we can do that really help us programming in the long run. And when we create a lot of these, or even just several, or even just one, it makes it really easy because we can kind of create our own objects. And they have their own specific features and functionalities, which is really cool, and it really expands the scope of programming that we can do, and we can make really, really cool stuff with this.